Continuing with solving trig equations, a little bit of a review. So if you have cosine of 2 theta equals -1, that 2 affects our domain. So this will become 0 is less than 2 theta is less than or equal to 4 pi. That means we get to do 2 laps around the unit circle. Now cosine equals -1 at pi. That would be the first lap around the unit circle. When you go again, that's 3 pi. So we have 2 theta equals pi and 3 pi. And one way that you can kind of think of this is that 1 lap around, 2 laps around. We know that cosine is -1 right here, and that I've drawn 2 laps around, so I should have 2 answers. Getting theta by itself, theta is going to equal pi over 2 and 3 pi over 2. Done. Okay, now on this one down here, our domain is going to be affected by this dividing by 2, or multiplying by 1/2. So our new domain is going to be 0 is less than theta over 2 is less than or equal to pi. So we're only doing half a lap on this. So on our unit circle, we're just going to here. Now, cotangent is the reciprocal for tangent. So I'm going to write this as tangent of theta over 2 equals, the reciprocal for -1 is -1. It's quite nice that way. Now, if we're only caring about quadrants 1 and 2, tangent is only negative over here. So we're only going to have one answer, which is fine. So theta over 2 equals, we know that tangent is 1 at pi over 4. In order for it to be -1, 1 pi over 4, 3 pi over 4. Then to get theta by itself, we'll multiply both sides by 2. And this becomes theta equals, 3 pi over 2. And that's our one answer. Now, let's look at one like this. So our domain is going to change quite a bit on this one. If you have cosine of 2 theta minus pi over 2 equals -1. So what we have to do to our domain is first multiply it by 2, which would make it 0 less than 2 theta less than or equal to 4 pi. And then we need to subtract pi over 2 from all of these. So like minus pi over 2, minus pi over 2, minus pi over 2. So 0 minus pi over 2 is negative pi over 2. In the middle, 2 theta minus pi over 2, which is great because now that gets us what we have in the original problem. And then over here, if we do 4 pi minus pi over 2, well, that's like saying 8 pi over 2 minus pi over 2. So this is actually going to be the same thing as 7 pi over 2. So I'm going from -2 pi, negative pi over 2 to 7 pi over 2. Now, if that's our new domain on our unit circle, negative pi over 2 is down here. Okay. 7 pi over 2 is also down here. Okay. And we know that this is also the same thing as 3 pi over 2 and 7 pi over 2. So we start from negative pi over 2, loop around, that hits it at 3 pi over 2, and then we loop it around again, and that hits it at 7 pi over 2. All right, now we want to know where cosine is -1. Well, we know that that happens over here at this ordered pair, -1, 0. So how many times did we loop around and hit this part of the x-axis? Twice, so we're going to have 2 answers. So even though our domain looks a little funky, we're still going to have just kind of a small number of answers, and that's okay. So 2 theta minus pi over 2. This happens at pi and at 3 pi. So I'm going to write this out twice. So I have 2 theta minus pi over 2 equals pi. I need to solve for theta there. And then I have 2 theta minus pi over 2 equals 3 pi. And I need to solve for theta here. So right here, we're going to start by adding pi over 2 this becomes 2 theta equals 3 pi over 2. And then we're going to divide both sides by 2, which will give me theta equals 3 pi over 4. And that's one of my answers. Down here, I need to add pi over 2. So we have 2 theta equals 7 pi over 2. Divide both sides by 2. Theta equals 7 pi over 4. So my two answers for this equation are that theta equals 3 pi over 4 and 7 pi over 4. There we go. Okay, something that we need to recall is we talked about fundamental trig identities, and the big one is sine squared of theta plus cosine squared of theta equals 1. That's the biggest one, the most important. If you can't remember anything else, remember that one because everything else comes from that. And then there's what I call variations of it. And if you just do some basic algebra and rearrange this equation, if you subtract cosine squared on both sides of the equation, on this side, that would leave you with just sine squared. And over here, it would look like 1 minus cosine squared. So I can write that 1 minus cosine squared equals sine squared of theta. And I could also write 1 minus sine squared of theta equals cosine squared of theta. And those are just variations of this one right up here. Okay, that will come in handy later on. Now, let's take a look at a trig function like this. So I have 2 sine squared x minus 3 sine of x plus 1 equals 0. And we need to solve for x. This is a quadratic equation. It just happens to include trig functions. Okay? And it's quadratic because that's squared, and this is to the first. So whenever your first exponent is twice as much as the second exponent, it is a quadratic equation. Now, our favorite way to solve a quadratic equation is to factor. So, give myself my 2 sets of parentheses. Okay. Now, I need to have 2 sine squared of x. So, I'll know I have 2 sine of x and sine of x. Now, down here, it's got to be 1. The only thing that multiplies to be 1 is 1. Since it's addition at the end, subtraction in the middle, minus, minus. And just checking to make sure that it works out. If you FOIL this, 2 sine of x times sine of x is 2 sine squared of x. 2 sine of x times negative 1 is negative 2 sine of x. Negative 1 times sine of x is negative sine of x. And negative 1 times negative 1 is positive 1. If you have negative 2 sine of x and negative 1 sine of x, that would make negative 3 sine of x. And then this is 2 sine squared of x minus 3 sine of x plus 1. That's what we originally started with. Cool, we factored it correctly. All right, now once you have it factored, set each set of parentheses equal to 0. So this is saying that 2 sine of x minus 1 equals 0, or sine of x minus 1 equals 0. So sine of x equals 1/2, or sine of x equals 1. We do not have to change our domain because it's just x by itself, like it's not sine of 2x or sine of x over 2. All right, well, where is sine, your y value, equal to 1/2? Well, that happens at multiples of pi over, excuse me, 6. First quadrant and second quadrant, so pi over 6 and 5 pi over 6. The other thing is we need to figure out where does sine equal 1. Well, there's only one place where that happens, and it's at pi over 2. There you go, solved. So it's a quadratic equation, which means we factored to solve it, and then you set each factor equal to 0, and you solve each factor separately, just like we've been doing before. Okay, now, let's take a look at this problem up here. We have 3 cosine of x plus 3 equals 2 sine squared of x. Definitely a quadratic because you've got the squared here and then to the first power here. The problem with this equation is that there's 2 different trig functions going on. And you can't solve for 2 different trig functions simultaneously, just like you can't solve for 2 different variables simultaneously. So what we have to do is we have to make the equation in the form of just one trig function. We can't really do anything with cosine of x, but with sine squared of x, using our fundamental trig identities, I can rewrite that as 1 minus cosine squared of x. Okay, so that sine squared of x becomes 1 minus cosine squared of x. So now I've got 3 cosine of x plus 3 equals 2 times the quantity 1 minus cosine squared of x. We'll distribute the 2 through. Now we're just dealing with cosine squared and cosine. Move everything to the same side. We should be good to go. All right, so this is going to be 3 cosine of x plus 3 equals 2 minus 2 cosine squared of x. Always want your squared term to be positive. I'll bump that over. This is going to look like 2 cosine squared of x plus 3 cosine of x plus 1 equals 0. Your first exponent is twice as big as your second exponent. It is a quadratic equation. So factoring this, I need 2 cosine of x here, cosine of x here, multiply to be 1, means we got to use 1 and 1, positive and positive, so plus sign, plus sign. Set each factor equal to 0, so 2 cosine of x plus 1 equals 0, or cosine of x plus 1 equals 0. So I need to know, where does